Thank you, Oliver, for such a nice introduction. First of all, thank you so much for attending this talk and welcome to GopherCon AU 2023, right? So today I'll be giving you like basic insights about WebAssembly is, what WebAssembly is with Go, basically. And at the end of the talk, I would want that you will be going with what WebAssembly is and also with some curiosity that how you can explore it yourself, right? So yeah, my name is Jyotsna and currently I'm not working anywhere, I'm on a career break. That is why I mentioned out of office. And but prior to my career break, I've been working as a senior software engineer at a company, Gojek. And apart from these full-time job responsibilities, I have been a part of communities a lot, as Oliver was mentioning about me, right? So I have been a part of Mozilla for the last 7 years, and I've contributed to the add-ons community of Mozilla specifically a lot. And apart from that, I have also started, and we organize Women Who Go Bangalore events on a monthly basis, where we are trying to create more diverse and inclusive Go community in Bangalore, right? So if anything interests you, you can reach out to me at my Twitter handle, which is mentioned. I am Zainal, Twitter X, right? Yeah. So yeah, what's the agenda of today, right? So I'll be talking about what is WebAssembly thing, right? What is this thing which is so hyped out, right? So, and next, I'll also talk about why do we really need to care about WebAssembly. Third is what would be the potential use cases of WebAssembly, like what are the cool stuffs you can build using WebAssembly. And fourth, next point is how you can actually build a WebAssembly app using Go. So it will be a very basic one, but we'll see how you can proceed with that, right? And last one is how you can run tests in your browser. So we'll code, then we need to write tests, right? So how you can run those in your browser, that we'll explore today. This is the agenda. So yeah, as per the official documentation, WebAssembly, abbreviated as WASM, is a binary instruction format for a stack-based virtual machines, right? This is with technical. This is originally been, I have fetched it from webassembly.org, which is created by the creators of WebAssembly, right? So I understand this is quite technical, so I'll translate this into a very simple plain English so that everyone will get to know what WebAssembly is, right? Because I get it that it might be a very bouncer topic for most of us. So I would also like to pause here for a moment and understand my audience a little bit here. Who are familiar with WebAssembly? You can raise your hands. Okay, I see a couple of hands, but most of us are non-familiar, right? So it's the best thing for today because I have created the presentation in such a way that it is for mostly introduction and then you can use that after the talk. Yeah, so I'll just dissect that, whatever the original official documentation was written. So WebAssembly was announced in 2015. It was first released in 2017, right? So it's relatively new. But even though it is relatively new, it has become a standard language that all the major browsers can understand and execute, right? And since it is a machine language for the web, it is very faster in execution, which is why it gives near native speed. And this is why we call in fancy term that it is very super fast, right? And it has seamless integration with the JavaScript. And also you can run the WebAssembly in the sandbox environment in your browser engine itself. And this doesn't need any software or plugins at all. It's not like FlashPlayer or Silverlight, which came up with their own security headaches, right? So it's since it will be running in the sandbox environment, which is safe. So it will be enforced with the browser security policies. So ultimately, you will have peace of mind in terms of security risk when you are developing the code for the web, right? So we can say here, if I need to conclude, then I can say here is that it is like WebAssembly is a machine language for the web. So a lot of you might be thinking that JavaScript already exists, right? So why do we really need WebAssembly, right? Or few of you might be thinking that JavaScript will be replaced by WebAssembly. So I'll just make a statement here that JavaScript is a very versatile language. It's very amazing, but WebAssembly is not here to replace the JavaScript. It is on the other hand, in a way, has come as a companion to JavaScript. It will take the heavy lifting jobs, do the heavy lifting jobs that JavaScript cannot do at a highly performance speed, right? So, and yes, we can communicate with JavaScript functions and JavaScript with WebAssembly functions and vice versa with each other. We'll see how we can do that today. And next is, you might, like this is a basic structure. We'll understand the position of WebAssembly with respect to the JavaScript and hardware. So if you see on top of the stack is JavaScript, right? Since it is a high level language, right? Any human, like we can read it. So it's a high level language, so it is not near to the hardware. But WebAssembly acts as a bridge between high level language and the hardware. WebAssembly will not directly run on the hardware directly, but rather it is near native to the hardware. So this is what the position lies in, and which is why WebAssembly is closer to the hardware, and this is why it runs faster, and which we might have heard about it a lot. And yeah, so this is what I've already discussed a bit. Like it's near native, it provides near native performance, enhanced efficient execution, right? And WebAssembly also gives multi-language support. So for example, if you are good at C, or you prefer using C, C++, or Go, or Rust, right? You can use the same language and convert that same code of that language into WebAssembly module. So in a way, WebAssembly is platform agnostic, language agnostic. You can simply convert your code into WebAssembly module. And it has seamless integration with JavaScript, as I already mentioned. We'll see how we can use that, how we can integrate JavaScript with WebAssembly today. And last one is security, sandbox execution environment. So as I already mentioned, WebAssembly, it will be running inside the browser engine itself, and it will be running at the sandbox environment. So ultimately, it is providing a security. So it's safe, secure, and you don't need to keep in mind of the security risk at all, because all the browser security policies will be enforced in the WebAssembly as well. So you might be thinking that I'm repeating the same stuff, like in the what WebAssembly topic I was discussing previously, and now in the why WebAssembly, I am talking about the same things, right? It is because when WebAssembly was designed, right, it was designed in keeping a mind of these things, like how will WebAssembly will benefit, right? These are the strengths of WebAssembly. And if you really want to understand the performance versus JavaScript and WebAssembly, this is how the traditional workflow of JavaScript looks like, the top one. And the later one is WebAssembly's execution is a bit more streamlined. So if let's go to the JavaScript one. So you will see that firstly the code is parsed, and once it is parsed, it will convert into the data structure AST, and then finally into the binary code, right? And then we all know that JavaScript is a dynamically typed language, right? So it will also take some time to compile and optimize, and then also it takes time to execute that. But on the other hand, WebAssembly is directly a binary code format, right? So it is faster to decode, faster to compile, and the compilation process of WebAssembly and JavaScript are very different, because it's a statically typed language, and JavaScript is not statically, it's dynamically typed language, right? So JavaScript engine takes a lot of time. in that context. And finally, after execution in JavaScript execution, there is a garbage collection where memory free up happens. This is why like WebAssembly is faster than JavaScript, you can say, if you get into internals. And if we compare WebAssembly with other technologies, I've mentioned JavaScript again. So WebAssembly outperforms JavaScript and ASM.js in terms of execution speed. And since JavaScript is an interpreted language and the ASM.js is a subset of JavaScript, and you can say ASM.js has provided the evolution of WebAssembly actually. And WebAssembly executes at the near native speed thanks to the efficient binary format and the AOT compilation. Next is what we have discussed so far, right? I'm just encapsulating those things, those discussions into the 4 foundational pillars. First is performance, second is portability, flexibility, and security. If we go one by one, then performance, I'll bring back the same thing, near native performance, because I already discussed, it is near the hardware, it is in binary format. Your computer processor understands binary. So this is why it's faster, right? And by portability, I mean you can run your code in any platform, be it iOS, be it Android, be it your web browser, right? And by flexibility, I mean here is you are, as a developer, you will not be restricted to JavaScript only now. You can leverage Go, you can use Rust for doing the front-end task as well. So you can do the front-end work by avoiding JavaScript if you really want to. And next last is security, coming back to the same thing. It executes in the sandboxed in safe environment, which is why it provides a security to the web. So far we have seen the theoretical things. You might be curious to understand that what would be the use cases of WebAssembly, what cool stuffs you can build using WebAssembly, right? So WebAssembly, as already mentioned, it is used for performing high computational tasks when it comes to JavaScript, right? So this is why the uses of WebAssembly are a bit related to performance criticality. So gaming, AR, VR, musical applications, image editing, image recognitions, video editing, encryptions, where security-related VPNs or remote desktops are being used. It is also used in desktop tooling like editors, compilers, debuggers, and it can be also used in CAD applications. So, and there are many more. I've also listed down the reference link, which you can check it out later after the presentation. So today, we'll be seeing a lot of talking has already been happened. You might want to, as a developer, you might want to say that, please show me the code, right? How can I actually build one? Rather than just talking theoretically, right? So we'll see the basic Go code, which you will be running on the web browser. You will see how you will bring life to your Go code on the browser directly. And it would be a basic one, but please understand the workflow of that Go with WebAssembly and then to the web browser. So the steps are 5. First step is we'll write some basic Go code. And then second step is we'll compile that Go code into the Wasm module. By Wasm, I mean again WebAssembly. It's a short form for WebAssembly. And third one is we'll write some HTML code. Fourth is we'll copy some JS glue files. As I already mentioned that WebAssembly cannot be run on the browser directly. It needs to be interacted with JavaScript. So some JS glue code will also be required. So which is why we'll be doing some copying of the JS glue files which are already provided in the Go installation. And next is last, we'll be serving the files so that you can view the Go code actively live on your web browser. So yeah, this is the entry point. Any Go programmer can understand this, but if you are not a Go programmer, I'll just tell you what we are doing. We are just using the println function of FMT package, where we are trying to print this statement, Go WebAssembly, on the console. In our use case, we will be printing this, on the console would be browser's console for us. So at the end of this application, if you are able to see Go WebAssembly in your browser's console after starting the server, then it means that you have successfully created your Go WebAssembly app. Next step is writing the index.html. This is a skeleton, or you can say boilerplate. You can get it from the Golang Wikipedia of WebAssembly as well, but I'll make you understand a bit. So if you see the wasm_exe.js, right? It is the same JS glue file which I was talking about, which you will be copying from the Go installation, and which we are importing into, or we are loading into our index.html. Next is constant Go and new Go. We are just creating a instance of Go, which is a part of this wasm_exe.js. And next, the third line is WebAssembly.instantiate streaming, where we are using the fetch API. We are fetching the main.was, which we have created from Go code to the WebAssembly module. So main.was is the WebAssembly module which we have compiled from our Go code, right? So this is what we are fetching from the fetch API, and this instantiate streaming will ultimately create it will compile and create an instance of the WebAssembly which could be used. And if you see the Go run, right, result in .instance, we will be using that instance to call the list of the WebAssembly functions, which you can import, like call it from JS itself. So this is where it will be used, and this is a basic skeleton. You will be needing at least these things for your basic app, and if you're going to build something better, then these will still remain. Now the third step is you have to run these following commands. First one is how you can compile the Go code into WAS. The first command will actually tell your compiler to target the WASM as the like WebAssembly as the architecture, which I have mentioned Go arc equal to WASM, and one point is Go OS is JS here, and this will actually create or compile your Go code, that original main.go into main.wasm. So first statement is simple. It will just compile your Go code to main.wasm module. And second point is how you can copy your JS glue files. You can just, as I already mentioned, it's provided by the in the Go installation itself. So you just need to copy it, and using this command, you will be getting this wasm_exe.js in your current root directory, current directory. And third is you will be serving the files. This single line will be helping you to start the server at port 9090, and directly you will be, when you will be accessing that index.ml file, you will be directly seeing in the console of browser that you will be seeing the text which we have, or any logic which you have been writing in your main.go. So this is how you will be checking or confirming or verifying that your Go code is now a part of web browser. So this is a snapshot which I have taken. After I have ran those three commands, I've started the server at local, and I went to the browser and just typed localhost 9090, and it will open a blank page. And I just opened the console where you can see the Go WebAssembly in the console, which means that now your Go code is finally able to be live on your web browser. Yeah, this is it, like in terms of coding. But if you really want to understand summation of this, you will see, like, this is a workflow which I have mentioned to summarize whatever we have done in the steps. Firstly, the Go code you will write, you will compile it, it will be using Go compiler, it will be converted into the Wasm module, and then you will add some JS glue files, and you will import those in your HTML, and also like you will import that JS and also the wasm.module wasm file into your HTML, and then finally it will be that it will be live on your browser. So since we have done a lot of tests like coding, now you will be thinking how you can write some test cases, right? And current process is quite cumbersome. It's the same thing. You will be writing some code, tests, and then compiling it to the WAS module. And then you will be needing to load those WAS module and JS glue files into the index.html, and then finally running it on the web browser using starting the server, right? It's again 3 steps. It's quite cumbersome. So there is a tool which you can use it directly, Wasm browser test. It automates all these previous steps. For this, you just need to type goos equal to JS, goarch is Wasm again, and then go test. It will simply automate these steps, and the link I've also given the repository link. I will see there are some companies, big companies, large companies, which are already using WebAssembly in their production. Figma is one of them. Google is using for Google Earth. Microsoft is using for Microsoft Blazor tool. Unity is also using, it's a gaming development engine. AutoCAD, Adobe is also using WebAssembly right now and in production. It's not a theoretical concept, it's already live in production. Finally, you must be wondering, like, have there any been projects or case studies which are related to WebAssembly with Go? Yes, there is. So I've mentioned a couple of repositories or projects. One of them is TinyGo. TinyGo is Go compiler for some small places, microcontroller, WAS, CLI. Vecti is like, it lets you build responsive and dynamic web front ends in Go. If you are a backend developer like me, you can just use Vecti to build front end in Go. And third is Wasm Go. It's same CLI. It's a straightforward approach through the steps which we have done. It's just a CLI to compile the Go to Wasm and serve it locally. What we were doing manually, it automates that whole process. Last one is Shimmer. It is for image transformation in Wasm using Go. So this is a tweet done, like created by the founder of Docker, Solomon Hykes, and he has mentioned that if Wasm plus WASI existed in 2008, we wouldn't needed to create the Docker, right? So it's a very big statement coming from the industry leaders like him, right? So you might be wondering that what is WASI here, right? Or WASI. So it's, since the scope of this talk is limited to WebAssembly, so I'll just restrict here to WebAssembly, but I am giving you a just a topic like which you can search or explore after this talk. So WASI is a WebAssembly system interface. So let's say right now we are focused WebAssembly in browsers, right? But let's say if you want to run WebAssembly outside your browser, then you can do that using WASI. And this is a really innovative tool which you can actually check it out. It's very great, amazing. I would encourage you to check out after this talk. These are the resources which I have created, handy links. I've used personally for my own learnings, and you can find it out yourself. I have created them for you to keep them handy. Just, I'll share the slide link also. You can just take my slides also later and then use those resources later as well. Thanks a lot everyone for attending my talk and being patiently listening my talk. And thanks to the GopherCon organizers for being so amazing. And if you want to reach out to me later, if you want to have a conversation with me related to communities, Golang or this WebAssembly, feel free to ping me on X or Twitter, previously Twitter. This I am Zainal. You can just reach out me there. We'll have a conversation there. Slide links is there up. You can directly access it right now if you want. That is all for the day from my end. And thanks again, everyone.